Hello everyone, myself Professor Ashok Kumar. I am working in Department of Mechanical Engineering, Technical Chemicals. First of all, you are warm welcome to my video lecture series. And as you know that we have discussed chapter number 6, gear trains as a part 1 in my previous video lecture. So this entire video lecture in which we will basically discuss on the remaining portion and part of the same chapter, gear trains. As you remember that in particular my previous video lecture on the same chapter, gear trains, we have discussed about an introduction of gear train techniques, in which specially we have discussed a lot about the basic concept of the gear trains, its application, attachment detail, actually where it is used, techniques, its applications area, and we have also discussed about the types of gear train, commonly and very simple gear trains that are being currently and widely used for various places, like the simple gear train, compound gear train, of course reverted gear train, and finally epicyclic gear train. At the end of the video lecture, we have also discussed about the velocity ratio calculation for an epicyclic gear train. So today we are going to discuss one more content of the same chapter, and that is the type of gearbox. All of us have listened this word gearbox, especially whenever we are talking about gearbox. Your focus should be go on an automobile, especially because in automobile there is a gearbox and we are using for shifting of the gears as per the load and torque requirement. So basically the prime function of the gearbox is to supply the power and torque as per the load requirement. Suppose you are riding in a vehicle like a bike or car, and in some instance it's not necessary that during your entire path or entire journey the load requirement and the engine is same everywhere. It may be possible that from A to B distance you require more speed, from B to C you require more load or torque. So ultimately your the requirement or gearbox or requirement, or you can say that the bike requirement will differ from time to time. So ultimately in order to issue, or you can say that in order to supply the changing in torque and the motion, we are using gearbox there. So over here in this case we are going to discuss the types of gearbox. Generally gearbox is known as a box which contains the numbers of gears, simply known as a gearbox. Generally it maintains engine speed at all conditions of load and vehicle speed. Also gearbox are also used to enable the engine to run faster in relation to the road wheel, as well as the multiply the torque. This is very some auxiliary application of the characteristic of gearbox, because it may quite possible that while you running your vehicle, the speed of your vehicle will be less as compared to the speed of the gear or speed of the crankshaft of your engine. So it indicates that the speed of engine is no longer same as that of your vehicle wheel, because frequently we require to change the speed as well as the torque. So whenever you require higher torque, at that time speed will be decreased, and whenever you require higher torque, of course the speed will be decreased. So this is the two condition or criteria in which your gearbox is going to be worked. Most commonly gearbox generally used, so what I said, in automobile, generally some specific machinery wherein gearbox generally are being used. So first and most important type of the gearbox is the sliding mesh type of gearbox. Generally this type of gearbox is very simple in construction, and this type of gearbox contains all the gears in specific housing called body. So you can see here from the figure that all the gears are enclosed in a common body, and it will be known as a anti-gearbox. Generally, the clutch gear is rigidly fixed to the clutch shaft and it remains always connected to the drive gear of the counter shaft. You may also see from the figure that the clutch gear is permanently fixed to clutch shaft and it always remain with the connected position with the driving gear. As you see from the figure that three other gears are also rigidly fixed to the counter shaft and they are second, first and reverse speed gear because as what I said earlier, we not only require to maintain or the high speed, but we require frequently changing of the torque as well as speed too. Generally, in a normal automobile vehicle gearbox, what happens? First gear stands for the higher torque, second gear is intermediate gear, whereas third gear, say, the lower torque. But meanwhile, first gear, of course, gives the higher torque, but it gives low speed, very much low speed. Intermediate gear having the moderate speed, whereas the third gear has the high speed but very low torque. This is what the phenomena of different gears that are mounted on sliding mesh type of gearbox. Generally, two gears are mounted on the spline main shaft and which can be slided by the shifter yoke when the shaft lever is operated. As we know that we require to have some shifter to engage the driving and driven gears. So over here we are using three types of gears. So whenever you require to mesh that each of the gear with the driven gears, at that time you require to have some kind of yoke, shift lever. And it is operated mainly in case of heavy loaded vehicle by hand operated lever, whereas in case of two-wheeler bike we are using foot power to shift the gears. Generally, this is very much a common type of the gearbox that is being widely used in automobile. As I said earlier, also you find its application in some specific machinery where during to perform some operations we require some kind of the higher working duration of some periodic time, whereas the remaining ideal stroke for ideal periodic time we require higher speed and low torque. If such a variation of the requirement of torque and speed come across, of course we should use the sliding mesh type of gearbox. You have given two diagrams. From the diagram you can easily understand. Look at the right hand side diagram. There is a main shaft and over which three gears are mounted, whereas there is one counter shaft over which there are four gears have been mounted. So gear D over here represent neutral gear. If you are neutral gear represent the ideal motion of your automobile engines, whereas from the figure you can easily understand that over here there is a pair of two gears that are being meshed with each other. So whenever the power or torque from the main shaft is coming to these gears, it will be transmitted directly to this gear. One more thing that should be discussed herein is that the diameter of the gear which is mounted on the main shaft is very much less as compared to the gear which is mounted on counter shaft. So it clearly means that it's the transmit in this condition the velocity ratio of currently whatever the power is going to be transmitted, velocity ratio is very low because there is a huge difference between diameter. So it strictly indicates that in such a condition, such a assembling condition between two gears, the torque requirement is high and the speed requirement is very low. In similar manner, you can pair the remaining different diameters of the wheel or gear wheel to its meshing gear, and meanwhile you will have different kind of the torque requirement and speed requirement you are getting through this meshing. After the sliding type of gearbox, there is one more type of gearbox, and that is the constant mesh gearbox. Generally, in this type of gearbox, all the gears of the main shaft are in constant mesh with the corresponding gears of the counter shaft or tail shaft. So first point that you should to understand is that as you are comparing with sliding mesh gearbox, over here in this constant mesh type of gearbox, all the gears are remain in meshing position with its mesh gear in every time. If you have the gone through the previous slide, you may have seen that out of 3 gears at a time only one gear is meshed with particular gears mounted on driven shaft. But in case of constant mesh type of gearbox, all the gears, you can see from the figure that all the gears are meshing with each other at every time of periodic time. Generally, two dog clutches are provided on the main shaft. One is in between the clutch gear and the second is first gear and the reverse gear. So, two clutch dogs plays a vital role for the power and torque transmission, for the meshing of the gear pair, and dog clutches can slide on the shaft and rotate with it, while all other gears on the counter shaft are rigidly fixed on the respective shaft that are being used here. Now, as and when the left hand dog clutch is made to slide to the left by means of the gear shift lever, it meshes with the clutch gear and the top speed gear is obtained. That means in that way you are getting higher speed whenever you mesh with the top gear with respect to relevant gear in particular periodic time. When the left hand dog clutch meshes with the second gear is obtained, and similarly in that same manner, by sliding the right hand dog clutch to the left and right, the first speed gear and reverse gear can be obtained. So ultimately here, your requirement for the variation of speed and torque will be obtained by sliding left as well as right dog clutches, and in that way you just pair with shaft. You can pair the different gears, and ultimately you are getting the variation of the torque that you require, variation of speed that you require for your bike or even machine's operations. Generally, in this type of gearbox, all the gears are in constant mesh that we have already discussed, and for this reason, they are safe from being damaged and irritating, grinding, sounding. Generally not happen this because of constant meshing. So this is the special case of gearbox, special types of gearbox, that is the constant mesh gearbox. After that, there is one more type of gearbox that we are coming across, and that is epicyclic gearbox. Generally, during my previous video lecture, we have discussed a lot about epicyclic gear train. So same gear train is mounted over here in order to achieve the different variation of speed and torque. As we know that in case of epicyclic gear train, there was a one sun and there was a planet gear pair which are messing with each other, and both are gears, or we can say that both of the gear wheels are connected with a common link, and that is the arm. So if you are fixing that arm, it will look like as a simple gear train, but if you are unlocking or not fixing that particular arm, it will work like an epicyclic gear train. So that particular epicyclic gear train, if you are adopting the same for the gearbox and you achieve the different speed and the torque requirement to your vehicles, of course the gearbox will be known as epicyclic gearbox. So over here, mechanism that is being used in epicyclic gearbox, that is the epicyclic gear train. Now, generally in epicyclic gear box, what happens? At least one gear not only rotates about its own axis, but it also rotate about the bodily and others regarding the other axis of shaft too. So that means over here, gear is not fixed to rotate about some particular axis, but that axis on which the gear is mounted will also rotate with relevant to other shaft axis. This is the specific characteristic of epicyclic gearbox. Generally, epicyclic, or we can say that sun and planet type of gearbox, generally not using any kind of sliding doors or gears to engage and disengage, but different gear speed are generally achieved through tightening brake bands on the gear drums, which generally simplify the gear changing. That is the other prime characteristic if you are epicycling using epicycling gearbox. You can see that from the figure. There are no any kind of sliding doors or the gear shifter, but in place of sliding doors or the gear shifter, we are using brake bands over here. If you are tightening band brakes, you will have the power transmission from one gear to other gear. In that way, by simultaneously you are tightening any pair of gears, you will have the different velocity and torque. Generally, look at the screen, it shows the working of epicyclic gearbox. Generally, the compound gear ACE is mounted on a pin fixed to a wheel G, and the compound gear is free to rotate on the pin, whereas gear A, C, and E are meshed with the three different gears like B, D, and F respectively. Generally, these gears B, D, and F are connected in turn to the drum H, J, and K. And the drum H and J have the brakes in their outer circumferences, and the drum K is provided with the numbers of clutch plates. So this is what the construction of an epicyclic gearbox. Now, hub is generally fitted to the spigot shaft, and spigot shaft generally represented by capital N, and to which numbers of clutch plates are attached. So this is the hub constructional detail. And when a number M is pressed, that means the outer peripheral surface, if you are pressing it against the clutch plate, it will engage to the clutch, and thereby it will be connect the shaft to the output shaft P. So over here, engagement and disengagement just is possible by pressing the outer plate M, and in that way you have the assembly with both of the shaft, and you are getting required speed or torque. Generally, it is top speed gear. Now, in order to have the low speed gear, just you require to disengage the clutch and apply the brake on the drum J. Suppose now you require for some periodic time you require low speed. So ultimately you have to remove the external force that you have applied on outer surface of M, and meanwhile you have to apply the brake bands that are being mounted on that particular plate above the plates. So what happens? Due to brake bands, the speed will be decreased, and ultimately at the output shaft you will have the lower speed. This is the phenomena how one can have the higher speed and lower speed, and higher torque and lower torque. Now this if you are doing so, it will lock the gear B, and thereby decreasing the speed of gear B, and so the speed of output shaft will be decreased. Now, after getting higher and lower speed, it may possible that during some periodic time you require reverse gear, or you require to have the reverse speed of your vehicle. At that time, just you have to apply a brake on the drum M, and if you are applying brake on drum M, it will lock the gear F. Thereby, there will be a reverse direction of rotation of B. With respect to the input shaft, and the speed B will also of course reduce and reverse. So in that way you are getting the reverse direction of motion, that means reverse speed as you require. So dear student, the entire lecture we have discussed primarily three basic types of the gearbox: sliding mesh, constant mesh, and of course epicyclic gearbox. Still you are finding any difficulty regarding any content of this video lecture, let me inform. I will have the solution for each and every types of gearbox. Thank you very much.